Hey, these are the notes for Integrated 2, 4.1.1. The entire chapter we're going to be factoring, so some of you may actually enjoy this because it goes back to stuff that we were doing probably a couple weeks ago. So, as you recall, we were able to write things as a sum and as a product. As a product means that you are multiplying factors, since it is a product, so we do a multiplication. And then as a sum, each one of the terms is separated by addition or subtraction signs. So there is no multiplication that is occurring between factors for the sum part of it. So we're going to primarily focus on being able to use the tiles on this, but please understand, I'm not stopping you or slowing you down from using the generic rectangles either. So if we take a look at question number 1, we want to be able to take a look at this tile pattern and the tiles that have been identified for us and see if we can write this as a product and as a sum. So let's go back to stuff that we had done previously. So if I take a look at this, we have this XY tile, so I'm going to start in the bottom left-hand corner. We know that the XY tile has dimensions of X and Y because that with the dimensions of X and Y, if we multiply them, we get XY for the area, so the thing that's inside. So we basically have these two dimensions that we need to figure out. Well, we've got this one across the bottom that is highlighted in green, and then we also have the other one that is vertical there. Those are going to be two totally different dimensions. One of them's X, one of them's Y. That's why if you take a look at the tiles next to the XY tile, I placed another tile there with its area as well. So, excuse me. So if we were to take that green length and slide it directly up, since these are rectangles, I know that that green length is equivalent to the green length that I drew on the bottom. Well, that green length, based off of the fact that it is on a Y tile, and it is the longest side on the Y tile, I know that that length, that green length, is going to have to be Y, which means I can drag that green length of Y all the way down. So now if I take a look at any of the rectangles, so within the red box, that are directly above that Y length across the bottom, then I know that the dimension or that length for every single one of those boxes is going to be Y. That sends us back to the dimension that gets us to the XY tile. So if the green length is Y, then that means by default the blue length is going to have to be X. All right, so let's continue up, taking a look at the different tiles above the Y. All right, well, I have another one up here as well. If I take a look at the Y tile, so the first Y tile, I also know that there's this dimension that I just colored in purple. Well, if you think back to a Y tile, we would say that the dimensions are Y and, well, it's going to have to be 1 because 1 times Y, so purple on the outside times green across the bottom is going to have to give us the area of that Y tile. So I do believe that those smaller lengths are going to be 1. Now, if you keep looking up, this green length can keep being dragged up. So we know the green length is Y. Well, it's the same tile from below. So we have this purple length as well. They are identical, which means that length is 1. So I should be able to keep dragging up and looking at these purple lengths being 1 unit. Likewise, I can do the same thing and drag the green up. So we know that the area of every single one of these tiles is going to be Y because it is 1 times Y. And I am going to go ahead and fill them in because I want to write this as a product and as a sum. So we want to figure out everything inside the tiles, and then I also want to know the base, so how long they are, compared to the height. All right, so I think we have all of the tiles that have been built above the Y. So let's build off from the blue X length. So if I have that blue length, let's go ahead and drag it across, then that length is also X. Well, if that length is x and the area inside that tile is x squared, the only thing that this dimension across the bottom could be is x. So I'm going to go ahead and color code that blue since my x length here has been blue. All right, let's go ahead and drag that blue length up so we know that that is x. I'm also going to pull in that purple length from the corner. So that purple length from the corner was 1, which means I am going to do 1 times x to fill in that tile. Then I can go through and follow the same process. So each of my purple lengths is 1. And dragging that x length up as well, I should be able to find the area of each one of these, which is going to be 1 times x, which is x. Okay, moving on now down to the bottom. Well, I'm going to grab the x over from the left-hand side still, so that's still x. But if you have a dimension of x and you have an area of x, then the base of this is going to have to be 1. So that length is 1, which we've already color-coded as purple, so I may as well stick with that. So now I know that all of these lengths dragging straight up are 1 unit. Likewise, on the left-hand side, so I'm going straight up from the 1, the left-hand side dimension is still 1. That hasn't changed. So now I have all of these 1 times 1 squares. So the area of those are going to be 1. And let's go ahead and finish this last one. Same idea. Let's drag the x length over from the side. But you'll notice that the tile that we've already organized here or figured out is x. But if you look right next to it, it's the exact same dimensions as it. It's the same size. So I'm going to say that the area of this is also x. Also, I can look at the bottom and notice that those dimensions across the bottom are also 1. So I think I'm going to have some more of those 1 by 1 tiles here as well. So let's go ahead and fill those areas in. And then we know this length is 1. All right, so last thing we need to do is take the information here and write it as a product and as a sum. Okay, the product is the stuff on the outside. So we're going to have base times height. So as a product, and then as a sum. So we'll separate them. So the product on the bottom is going to be, well, there's no negative signs here, so we're going to go with positive. It's going to be y plus x plus, and then it looks like we have 2 1s. So 1 plus 1, that gives me 2. That's going to be the base. Now let's do times the height. So the height looks like we have an x, and then it looks like we have 4 units. So there we go. That's going to be our product, since this y plus x plus 2 is the base, and x plus 4 is the height. Now to do the sum, we're just going to go ahead and add up all of the tiles inside as like terms, so just be careful. We have 1 xy tile plus, looks like we have 4 of the y tiles plus a single x squared plus, looks like we have 2, 4, 6 x's, running out of space, plus, and then 2, 4, 6, 8 unit tiles. And I think that's going to be our answer here. So it's use of being able to use the algebra tiles to be able to factor, basically. Okay, moving on. We want to be able to write as a product and as a sum. So as a reminder with this, I am going to go ahead and build them. As a reminder with this, though, we typically put the x squared tiles to kind of start this thing in the bottom left-hand corner. So I'm going to go ahead and start building this. So I'm going to take my x squared tile, and I'm going to have 2 of them. Now you can stack them on top of each other, like so, or you can put them side by side, like so. It's ultimately up to you. I think I am going to go ahead and stack them up. Again, not that it matters. So that takes care of our x squared. So we have our 2x squared tiles have been handled. Now we have 7 x's. We're going to have to figure out how we're going to arrange these x tiles. So we'll slowly start placing them. And we're trying to create a rectangle. So if I put 2 here, I would have to have a third one up there. And I'll get to the units in just a minute. So that's 3. If I put another one up here, make sure I don't go over unit tiles. So I'm going to have 6 unit tiles. Okay, I've got room for 6 unit tiles. So that's going to be 4 x's. So I could do 5, 6, 7. So here's one arrangement. Now it looks like I am not sure I have all of the x's that I need, or all of the units I need. So there's 1, 2, 3, 4, 5. Okay, let's do a quick check on this. So I have 1, 2, 3, 4, 5, 6, 7 x's. Okay, that's what I need. 2x squareds, that's what I need. 1, 2, 3, 4, 5 units. This isn't going to work. So we have to fix the configuration. So maybe we put some x's off to the side instead. So I'll go back and we'll grab some more of the x tiles. So maybe we slide them over here instead. But every time I put 1 down there, I'm going to have to put 2 down there as pairs so I don't have these big openings. Okay, let's check. I've got 1, 2, 3, 4, 5, 6, 7. Cool. All right. Now let's see about the units. So there's 1, 2, 3, 4, 5, 6. Okay, good. We got it. So double check. I have the 2x squared tiles. I have the 7 purple x's that I found. And then 1, 2, 3, 4, 5, 6 unit tiles. All right. Now all we need to do is figure out what the dimensions of this are. So let's take a look back. Remember that this was an x squared tile. So the dimensions of that are x and x. If the height here is going to be x, then that means this dimension is also x. So I'm going to slide that x over, which means I think the only slender algebra tile that I have that is an x dimension is an x tile. So I think that's 1. All right, well, same idea here. If this is x, then that's x, which means that's 1. All right, let's keep going. Okay, so if this dimension across the bottom of the x squared tile is x, if we drag that up, that dimension is x. Plus, we already know that this is an x squared tile, which means I think that's going to be x as well. And then if we keep dragging it up, this dimension, so at the top of the x squared tile is x, that looks like a dimension of 1, so I think that's an x tile, which means that's an x tile, which means that's an x tile, which is exactly what we planned them to be when we were placing them. And then we know the green guys are the ones that we chose to put in. Okay, I think we have the base and the height now. So it's already written as a sum. We're going to write it as a product. To write something as a product means to factor. So looks like across the bottom we have x plus 1 plus 1, which we know is 2. And then we have 2 x's plus 3. Now, as a reminder, we did talk about generic rectangles previously, and this was where we started talking about the use of the diamond problems, which we can get to, but we are going to practice a little bit more with using our tiles. So why don't you see if you can do B? And then check your tile pattern against mine. See if we could factor it. Okay, so after attempting many configurations, this is the one that I got to work. So we want to have 3x plus 2 across the bottom, or you could have 3x plus 2 going up as the height, and then 2x plus 1 as the base, or 2x plus 1 as the height. All right, let's move on to C. On C, we want to play around with this a little bit, but I have a feeling we're going to have issues. So if we take out our x squared, and then we take out our 4x's, so I'm a big fan of just trying to stack them kind of all next to each other first if you're unsure, and then seeing that you only have one unit tile. Okay, so that's clearly not a rectangle, but that's all of the tiles that I'm supposed to be using. So I think what I want to do here is let's get rid of one of the x's on the right-hand side and let's move it on top. So just slowly start moving tiles from off to the right to up on top and seeing if that fixes the issue. I don't think it does. I still have the x squared though, which is good. I still have 4x's, which is good, and I still have the 1 unit tile. All right, let's move another one and see if that's going to help. So now I'll put this one on top. Closer, I guess, but I don't think it's going to work yet. So, all right, still have everything we need. Let's move another one over and see if that'll do it. Okay. Nope, I don't see this working. Because even if we move the last rectangle over, the configuration now looks like it did to begin with. It's just been turned on its side. So I still have my 4x's. Don't forget, I still have that 1 unit tile. So I don't think this is going to work. I don't think we can write this as a product, which means what we'd say is that this is not factorable. Okay, now we just want to be able to do the reverse. So in this situation, we have our generic tiles already built for us. Our job is to go through and divide. So I like to take a look at these as kind of like a greatest common factor, I think is the best way to put it. So I look at the base of this 6x squared tile. Now that blue length is going to have to be the same as that blue length across the top, which has to be the exact same length as the blue cross all the way across the top. So I'm basically looking at the 6x squared and the 2x, and I'm trying to figure out what do they both have in common. So if I take a look at the 2 and the 6, I know that that's divisible by 2. So I'm going to take a 2 out right by that blue length across the bottom. And then if something has an x and something has an x squared, then I think that that's going to have to be an x. So once I have factored that out, now the floodgates open. So all I needed to know really was just one of them. So now let's work on the other side of this bottom tile. So if the base of it is going to be 2x, then that means the height of it, well, what does it have to be to get the 6x squared that we're looking for? Well, 2 times 3 gives me the 6, and x times x gives me the x squared. Okay, now I know what that length is. That means that that purple length also has to be 3x, which means all the way across has to be 3x. So now, based off of that, I should be able to figure out the green length or the base of the 15x tile. All right, so I've got the purple 3x. So 3 times, well, 5 gives me 15. And then x times just 1 gives me x. So I don't think I need another x there. Okay, but now we can drag that green up. So if that length is green, which means the top length is green, we know that 5 times something, all right, let's color code that something orange. So 5 green times something orange is going to have to give us 5. So let's go ahead and drag that orange length all the way out. And the only number that will actually do that is 1. Now you got to make sure that the last box, the 2x, which we haven't checked, actually works. So is 1, the orange, times 2x, the blue, actually give us 2x inside the box? Yeah, I think so. There's no negative signs here, So we're just going to go ahead and rewrite it as the base, 2x plus 5 times the height of 3x plus 1. Why don't you see if you can do the next one? Okay, so check your answer against mine. Remember that you could do 5x minus 2 first and then y plus 3 second, kind of in the order that you would write things down. All right, let's try C. Okay, now, again, remember, you could have done 4x minus 3. You could even do negative 3 plus 4x. That's totally acceptable. You just need to make sure that one of the factors is 3x plus 4, so a positive 3x and a positive 4. And the other factor is 4x minus 3, or a positive 4x and a negative 3.